Hey guys, how are you? I hope you all are good. Today I am going to prove a theorem. There we have to show equal areas in parallelogram. That is in the chapter of area of parallelogram and triangle. See the statement of the theorem. Parallelograms on the same base and between the same parallels are equal in area. Meaning of this statement is two parallelograms are there. If they are on the same base and between the same parallel, then prove that their areas are equal. It means you have to prove that they are equal in areas also. Given two parallelogram that is on the same base and between the same parallel, ABCD and EFCD are two parallelograms are there. AF and DC, we can see those are the parallel lines. EF line on AB line, so they are between the same parallel. DC side is the base. We have to prove area, that is AR of ABCD one parallelogram is equal to area of another parallelogram, EFCD. As we already discussed, congruent figures have equal areas. See figure, here we can see two triangles and the middle part, that is like a quadrilateral DCEB, common for both the triangles. If we prove two triangles congruent, then it will be enough for getting the equal areas. What I mean is, if we prove two figures congruent, two triangles congruent, then automatically areas will be same. I explained in previous class about this clearly. Go ahead and watch and subscribe my channel. We know congruency figures have same size and same shapes. About congruency, I already uploaded a video on criteria for congruence of triangles. We need to prove three things to be same in two triangles. See the triangle ADE and triangle BCF given. When two parallelograms coincide, there you got two triangles. If you try to recall the properties of parallelogram, then you will find that two opposite angles and opposite sides are equal in parallelogram. Here we are talking about only triangles to make them congruent. We know the property of parallelogram, that is opposite angles are equal. Here angle A is equal to angle C. If we observe this side BC, angle B also equal there because vertically opposite angle. It means angle C is equal to angle B. For these two triangles, can I write like this? Angle DAE is equal to angle CBF. Here we are talking about only angle A and angle B. And these two angles are like corresponding angles also, because AD and BC are two sides and AF is a transversal. At the time also angle A is equal to angle B. Now next we have to prove angle E is equal to angle F. So see here EFDC also a parallelogram. There also we can use the property of parallelogram, that is two opposite angles are equal. If we take angle D and angle F, then see the side DE will get angle E also equal because vertically opposite angle. It means angle E equal to angle D, vertically opposite angle. We can see in two triangles angle E equal to angle F. So we can write it as angle AED is equal to angle BFC. So here also two angles become corresponding angles, that is DE parallel to CF and AF is a transversal. By taking corresponding angles also you can show equal angles. I am showing here two methods for getting equal angles. Here we got two angles equal. We already learned about angle sum property. If two angles equal, then automatically third side is also equal. Third angle is also equal. So can I say angle D is equal to angle C? And come to this side. We know in parallelogram opposite sides also equal. In parallelogram ABCD, AD is equal to BC side. Any one side you can take. Why? Because here we are applying one criteria of congruency of triangle, that is angle side. See in triangle AED, angle A, angle E and side AD. We shown two triangle congruent by angle side congruency. Or else you can use another criteria also. I already shown here. Because we got third angle also equal by angle sum property, we can use angle side angle criteria also we can apply there in triangle AED in both the triangles. So here we shown one side and three angles equal by ASA or AAS criteria. We can say two triangles are congruent. There are 5 different criteria are there for congruency of triangle. By using any one criteria, if we prove two triangles are equal, then it is enough to be two triangles are congruent. Can I write like this for two triangles? Triangle ADE congruent to triangle BCF as per ASA criteria. I written this equation. I am showing here angle A is equal to angle F, AD side is equal to BC side and angle D is equal to angle C by ASA criteria. You can watch the video of different criteria. There I explain this ASA criteria also in detail. I suggest you to watch the video and subscribe my channel. And also in previous video I explained two congruent figures have equal areas. So for our two congruent triangles, can I write like this? Area ADE is equal to area BCF because those two triangles are congruent. At that time their areas also equal. Congruent figures have equal areas. Two areas we found equal in two triangles. This theorem is not finished up to here. One more thing is there in our parallelogram. One more part is remains there, that is EBCD. We have to find the area of this part. Then only we can show two parallelogram have equal area. See the parallelogram ABCD, triangle AED. When we add this part, quadrilateral part, that is EBCD, we'll get the whole parallelogram ABCD. See the above equation. When we add to that equation this quadrilateral part EBCD, we'll get the complete parallelogram. Can I write like this? By adding the quadrilateral part in both the sides. Area of ADE plus area of EBCD, that is a quadrilateral part, middle part, equal to area BCF plus area EBCD. We know ADE and EBCD one parallelogram, that is ABCD. Area of ABCD is equal to area of EFCD. So parallelogram ABCD and EFCD are equal in areas. At last we proved it that parallelograms have equal in areas. The parallelogram which are on the same base and same parallels between the same parallel, those have equal in area.